So here's how you write tests in Unison. I'll walk through a couple things that you'll often be doing when writing Unison code. So first is watch expressions. This is more for kind of informal testing as you go, as you're developing. So you might have some code in your Scratch file, and then you just have these watch expressions, which are these lines starting with greater than. You save the file, the watch expressions are printed out. If the watch expressions have not changed, they actually just prints out a cache result rather than recomputing it. And this is nice just for kind of like making sure you're on the right track as you're developing your code. Okay, but then when you think you're sort of done, you're sort of ready to test things more rigorously, you can use test watch expression. So I'll walk through this. So you start, instead of just with greater than, you start with test and then greater than. And then you give a name. So in this case, I'll call this one basic examples. And then you say test.verify, which is a function that lets you give it a block of code that can do testing stuff. And so one of the things you can do within one of these blocks is you can ensure that two things are equal. So I guess I'll just accept this completion. Often, if you're using a coding assistant, it's often quite good at filling in these kinds of examples, especially if it knows what the function is supposed to be doing. So this shows that you can label tests if you want. It will, if the test fails, it's going to print out what the labels were. So if I change this to say a 0, it's not going to pass, and it's going to say, oh, that had the label test 1, and here are the two things that failed. In addition to using ensure equal, you can just say ensure. So you could say like list.sort of the empty list is equal to the empty list. The only thing about this is that if it doesn't pass, sorry, let me just fix that test that I had failing. So if it doesn't pass, then ensure doesn't tell you any information about what failed, because all you're doing is you're just passing a Boolean. So ensure equal, it's some diagnostics. So yeah, you can use ensure and ensure equal and labeled or labeled to just build up these little test suites that test for various conditions. I tend to be kind of lazy about labeling, honestly. I don't tend to put the labels in up front. I kind of just write things with no labels, and really only if the test fails, then maybe I'll go back in and add some more labels. But as long as the test is like kind of minimal and just kind of like testing one thing, I don't tend to label things. Cool. So that covers just writing some sort of basic tests. But what I like to do is I like to use property-based tests where possible. And so what that is going to mean is generating test cases programmatically, and then making sure that for each test case that's generated, there's some property that holds that we would expect to be true for a correct implementation. So some ideas for that for testing a sort function is that I would expect that it would be consistent with the implementation of sorted sets. So if I have a list of elements which are all unique and I sort them, that should give the same results as if I took all those same elements and I put them in a sorted set and then converted that sorted set back to a list. So it's kind of like, even though these are completely different ways of getting something into the sorted, we would expect them to be consistent with each other. I really like this kind of property because it's sort of building on something that already exists that you feel confident is correct. Even if you weren't sure if the sorted set implementation was correct, it would be incredibly unlikely that it would have the exact same bugs as the list.sort function, which is implemented in a completely different way. So this is like often just like a really nice lightweight way of constructing test properties. So within this test.verify block, you have access to randomness, and you also have access to non-determinism. So here I'm going to just say 1,000 times, I'm going to make up a list. This is not quite the property I want, but so I want to say that list.sort ends. Now, the only issue here is like ends might contain duplicates, right? So we can't just say like set dot from list ends set dot to list. That's no good because the set dot from list and then back to list is going to remove any duplicates, whereas list.sort is not going to do that. So one thing we could do is we could make sure that the list does not contain duplicates is we just say add a unique index onto each element. What is list.indexed? So it's if I have like a list, Alice, Bob, Charlie, let me just show this real quick. It just, creates a list of pairs where each element of the pair is like has a natural number that increases as we move through the list. So we're just using that here to make sure that all of our elements of the list that we're sorting are unique. And we see that this test still holds. So that's like a pretty good property. Anyway, I'll stop there. But you can maybe come up with other properties for, whatever it is you're doing. I like this kind of style of you come up with something that's in terms of something that already exists that you're pretty sure is correct. Okay, so once you're happy with your tests, first of all, I just want to reiterate that they are cached. So they're not going to be recomputed over and over again. But once you're happy with them, you can just add them to your code base. Cool. Now, if you just type the test command, you will see a report of all the tests in your code base. It's the report here, it's going to be divvied up into tests that were just cached and didn't need to be recomputed. And there'll be a separate section of tests that needed to be computed just now when you typed the test command. But anyway, this is just a Scratch project. I only have these 2 tests apparently. So cool. So okay, what about writing I/O tests? So integration tests. So not all tests are going to be deterministic. Some tests are going to need to do I/O. They are not necessarily deterministic, and they're not necessarily something you can just cache indefinitely, like pure code or pure tests. So how do you do that? So it's pretty simple. You actually do it in the same way. So I'll scroll down here. This is like kind of a silly example. But this is just like to show kind of how you do it. You're still going to use test.verify, or you can still use test.verify. Here I'm using verify with seed, and I am using, for the random seed, I'm using a random nat, which is fetched from IO, meaning every time I run this, it's going to get a random nat. Initialized by, system entropy, the clock time, things like that. So it's not going to be the same every time. Whereas if I just use test.verify, it is using a static seed for the random generation, and that's what makes it deterministic. Cool. So anyway, so I just write this test as normal. Basically, I can do the same sorts of things that I was doing before. So I'm still in one of these blocks. I still have access to randomness and non-determinism, and I can make use of that in my tests. But I also have access to I/O and really any other effect that I want, as long as I handle it before, I can use other effects, but I wouldn't need to handle those effects because the the only thing that you can have in test is you can have IO and exception as things that sort of bubble up to the top of an IO test. Anyway, if while I'm developing this test, I can just run it. I can say run list.sort.tests.io examples. Okay. And that actually ran the test and it passed. There's no caching that's happening here. Every time I run it, it's going to happen. If I want to just do some debugging, like, oh, it's not working, I might just, I don't know, do like, well, okay, I might say I want it to trace, this is probably going to generate a lot of output, but I might just say like, oh, what is ends? I want to know what that is. So I might say just debug.trace of ends, and then, you know, it's going to be printing out all of those. So you can add whatever tracing you want. And you can see if I run it again, it's still going to print out all those same things. So yeah, that's often what I end up doing when I'm like, if there's actually a bug and I need to like not cache anything, just like make sure it runs every time, I'll just run it as like a local IO test like this. Okay, but cool. So once I have this all working, I again could just add this to the code base. And now the test command is not going to run these, but if I do io.test.all, it will find all of the, this little formatting thing. It's going to find all of the tests that are basically like these IO tests and run them. I could also run an individual test. So I could say io.test. Actually, if you just press enter, I'd say like, I don't know, list.sort. Okay, just get a fuzzy find and I'll just run that one test. Cool. But yeah, now this is, you know, that's in the code base, and I can run those tests. I can run the pure tests. And I think that about does it. I hope you enjoyed this little quick overview of testing in Unison, and I will post some links to just the API docs for these functions that I was using. Okay.